trigonometry, we have no sound today or speakers because when I do, oh, now it's not buzzing. Well, that's fun. Okay, I guess we do. Yes. Oh, yes. Briefly recapping what we know about proofs, or the thought process behind a proof. Proofs are all about answering two questions. They are, Andrea.
What do I know, and what can I conclude?
What do I know, and what can I conclude? Okay. Start real. Big front. Every proof starts with that given statement with what we already know. We saw this in algebra. And everything after that is what can you conclude based on the information you are provided. Yes?
How many more objectives do we have?
I don't know. I'll check. But I'm not right now because we got to rock and roll here. The reflexive property of congruence for segments and angles. Basically, for angles, it says that something is congruent to itself. Okay? Angle A is congruent to angle A. Segment AB is congruent to segment AB. Whatever it is, something is equal to itself, congruent to itself. Oh, you want to do the next one? All right. All right, the next one, symmetric property.
The symmetric property of congruence is if x equals 5, then 5 equals x.
Yes.
Or it basically means the two parts of an equation or relationship can be reversed.
You were paying attention. Very good. Yeah. Symmetric property, basically, if x equals 5, we know that 5 equals x. Which is important because if you are told to prove in a statement that x equals 5, and the way that you solve it, you end up with 5 equals x, you've not completed the task. Okay? You need to then reverse that. Welcome back, Marcella. Reverse that so that it says x equals 5. Okay? That's where we left off. The transitive property. We've actually dealt with this one before in algebra, and I'll remind you of it once we cover it. Actually, no, I'll remind you first. So, do you recall in algebra when we learned about the zero power property?
Yeah.
Okay?
The base is 1.
So, yes, any base to the zero power equals 1, right? And the example that I gave you was we had just learned the dividing by the same base property. And so I related it to that, and I said that if you've got n cubed over n cubed, the powers are subtracted. What does this equal?
1.
N to the what?
0.
N to the 0 power. Using the dividing by the same base rule, this equals n to the 0 power because the powers are subtracted, the base stays the same. Okay? We also said then that according to our rules of algebra, anything divided by itself equals 1. And that is how we introduce the fact that any base to the 0 power equals 1. Because if the same thing equals two different things, these different things must also be equal to each other. The transitive property is what this is all about. It says if A equals B and A equals C, then
B equals C.
B equals C.
Or C equals then A is 0.
Okay? The transitive property relates three congruent things or equal things to say if A is B and A is C, then B has to be C.
And C can also be equal.
According to symmetric property. Look at you go. Nice. Okay? This one I want you to start. This one is going to be used a lot. Okay? If you only remember one of the three things on this page you've covered so far, let it be the transitive property. This one is used a lot. Okay? The right angles congruence theorem. You can tell by how much space you have to write. This one's a shorty, but it basically says that all right angles are congruent. Yep, that's what it says. All right angles are congruent. That's basically it. Mm-hmm. That's true. It's true.
That's nice E in it.
Yes.
How was it? Did they tell you that all right angles are congruent?
That statement right there is such a small percentage of my salary. It's probably literally pennies.
I should. Well, you still got pennies. This is so.
The congruent supplements theorem says that if two angles are supplementary, which what does the word supplementary mean again? They sum to be 180.
Yes.
Okay. If two angles are supplementary to the same angle, then the two angles, nope, are congruent to each other. Okay? If two angles are supplementary to the same angle, then the two angles are congruent to each other.
How's that work?
What that means is that if you have, let's see,
That they're the same to each other.
well,
Well, I guess congruent doesn't mean the same.
we'll call this A, B. They changed their mind. They don't want to talk to me. Oops. Okay. If you've got a diagram such as that, and then you have another angle over here, we'll call it EFG. Okay. If you are told that angle EFG is supplementary to angle ADB, sorry, ABD, not ADB, ABD, the vertex goes in the middle, okay? If you are told that angle EFG is supplementary to angle ABD, what is the conclusion you can make based on this theorem? Brielle.
They equal 180.
Good. Andrea.
That PDC and EFG are.
The conclusion is that angle DBC
Oh.
is congruent to angle EFG.
Wait, I got one. That's all I have.
Okay? Because, hold up, Cole, because being a straight angle, ABC, being a linear pair, we know that these two angles have to be supplementary by definition. Linear pair angles are always, right? So if you're told, hey, if you're told that EFG is supplementary to ABD, that means that these two angles have to be the same measure because DBC is also supplementary to ABD. Okay?
The wording was just confusing.
It is. We know, because these are a linear pair, that DBC is supplementary to ABD, right? Follow that? Okay? If we're also told that EFG is supplementary to ABD, whatever angle measure this is, there's only one supplement it can have, right? If this is 130, that has to be 50. If this is also supplementary to that one, that means that one has to be 50 as well. Therefore, the conclusion is that those two angles must be congruent. Okay, cool.
Well, so is it true that the area of the circle is when it comes to the outside?
I'm going to add that to the pip. Incorrect math formulas. Pivable offense.
That's a good idea.
Any questions on this?
This is not making sense.
Yeah, Brielle, because you're doing this with your hand sanitizer. You need to pay attention. What is your, what? Sam, no. Turn it on. Go ahead.
Never mind.
Okay, Sam, turn it on. Cool.
Can I ask a football question, please?
No.
No,
All right,
let me do it.
next page.
You can't say to watch the.
That's because we got too much to do, Cole. The congruent complement theorem is exactly the same, only instead of supplementary, you're going to write complementary. Okay? If two angles are complementary to the same angle, then the two angles are congruent. If two angles are complementary to the same angle, then the two angles are congruent. For example, how can we easily show in a diagram that two angles are complementary? What can I use? Sam?
Have a right angle.
A right angle symbol, right? Because complementary means 90 degrees. So if I've got two angles, right, with the right angle symbol there, that means that the two angles together add to be 90. The two angles together are complementary. Okay? Let's see. A, B, C, D, and then let's have another angle over here. We'll call it E, F, G. I think that would really confuse people if I started throwing Z's around like that. Okay? And if I told you, if your given statement was that angle ABC is complementary. Hold on. CBD is complementary to angle, hold on, EFG. No, I didn't confuse myself. Just hold on. EFG!
Can you put a hat on?
If you are told that EFG, my apologies, is complementary to ABC, okay, that means that we could literally take angle EFG and kind of stick it in where angle CBD is, and it would fit perfectly. Because if EFG is complementary to ABC, it has to be the same size or congruent to CBD. Okay? If EFG is complementary to angle ABC, and we know that these two angles are complementary because of the right angle, we can say that EFG is congruent to CBD.
What? So it has to be 45
Real,
degrees.
stop putting on hand sanitizer. Face the front.
I was.
Just Nathan.
So it had to be 45 degrees.
No.
This makes zero sense.
Complementary. All it means they add up to be 90.
I know. But like,
90.
ABC. If ABC is equal to right?
So the statement says. So this is where those terms come into play. If you don't know what complementary means, then this is not going to make a lot of sense. What does complementary mean?
It means two angles that have to equal 90.
Okay. Okay. So, and we know that ABC and CBD are complementary because of the right angle marker, right? These two angles have to add up to be 90. So if I tell you that EFG is also complementary to ABC, that means these two angles have to be the same.
I thought you meant that EFG was trying to fit into ABC. And I was
No.
like, what? Oh, that's gotcha.
No. EFG could slide into where CBD is and fit perfectly. Okay? Other questions on this one? It is a confusing wording. And again, that's why we, Colin? Will? Okay? Real?
Does that mean ABC is equal to CBD?
No. No. It does. I know. All it means is that they add up to be 90. We're not given angle measures, so we don't know. It looks like ABC is a little bit bigger, but it doesn't really matter. Because whatever this is, to sum to 90 with ABC, if this is 50, this has to be 40, right? If this is also complementary to ABC, this also has to be 40.
Oh, okay, I get it.
Charlie.
When are we getting our test back?
I'll take that off. Christmas present for my kid. I told you to put the hand sanitizer away. It was not put away. And so happy Christmas, Grayson. All right?
Happy?
I mixed happy birthday and Merry Christmas in my head.
Shame.
All right, any other questions on this one?
She has like 24.
Well, they're not out, so I'm not going to take them out. Okay, next one, vertical angles congruence theorem. This one says that vertical angles are congruent. Vertical angles are congruent.
Can you draw a diagram?
I will draw a diagram for you. What are vertical angles? We've covered this before. Yes, Cole? Vertical angles, Paisley?
Aren't the vertical angles the ones that look like an X, but
Yes.
the two sides are congruent to
Yep.
each other?
So when you have two segments, rays, or lines that intersect, vertical angles are opposite each other at that point of intersection. Okay? So these two angles would be congruent based on the vertical angles congruence theorem. Likewise, these two angles are also congruent. Thank you. Bye, please. I got it. Thanks. Yellow. He is just walked in my room and he's now walking out. Yep. No problem. Bye-bye.
Mr. Schultz, I'm
Yeah.
also missing Bluey Day and
We're not doing it. Blue.
oh, we're not. Oh.
Folks, shh. Okay. So at any intersection point of segments, rays, or lines, there are two pairs of vertical angles that are formed. Okay, and the vertical angles theorem allows you to conclude, prove that they are congruent angles. Okay. Linear pair postulate says that
Oh, I didn't draw a diagram. Actually, no, you did. Never mind. I said
two adjacent angles that form a line I'll put are supplementary. Which means they sum to 180 degrees. Linear pair postulate says two adjacent angles that form a line are supplementary, meaning they sum to 180 degrees. Cole, sit down. Nope. Tristan.
Is the entirety of PO16 just going to be what is the definition?
No, the next page of this, we actually are going to do some proofs. And so you'll be using these postulates and these theorems to write proofs. Kind of like we use the addition property, subtraction property, multiplication property. We use those to write algebraic proofs. We're going to use these to write geometric proofs. Okay, Colin.
What are we going to be tested on for this?
I'll show you soon. Just
Are we
hold on. This is part one. There's a part two to PO16. Yes,
I
Andrea.
have two questions. One, we already know this.
Yes, we have talked about linear pairs before, but we didn't actually name it as a postulate. It can be used in a proof, and we're going to be seeing that soon. Okay. A diagram for this one. Two adjacent angles that form a line. All we need to have is that diagram there, and we can say that angle 1 and angle 2 are supplementary. They form a linear pair. They sum to 180. Whatever information that we can pull from that, okay? Because there are two adjacent angles that form a line, we know that they are supplementary. Right?
what is adjacent?
Next to. Adjacent means next to. Or in this case, they share a side. Okay? Okay, Charlotte. I don't know yet. Anything else with this? Okay. A reminder, when we do proofs, which we will do momentarily here, definitions, postulates, theorems, they're all valid reasons. Definition of the midpoint, the distribution property, vertical angles theorem, linear pair postulate, they're all possible. So things that we've done in the past, remind yourselves of things like segment addition postulate, definition of a midpoint, angle bisector, all those postulates 5 through 11, and so on and so forth. Okay? All right, your next page where we actually start proving stuff. I'm gonna pause the video just. You now have PO16 part 2, which is where you actually get to write some geometric proofs. So unlike algebraic proofs, these involve geometric figures, diagrams, terms, things like that. But the proof setup is the same. So if we're doing number 1 here, it says given angle 1 is congruent to angle 3, and our job is to prove that angle 2 is congruent to angle 4. Right? So just take them in and look at the diagram. Find angle 1, find angle 3, find angle 2, find angle 4. Look at what we know, right? The proofs are what do I know, and then what can we conclude, and then how can we get there? Okay, you're writing a step-by-step recipe, a process for getting from the given statement to the proving statement. How do we start every single proof that we do, Maddie? The given statement. Even though it is written there for you, you still need to write it in your proof. Okay? So your very first statement is angle 1 is congruent to angle 3. And the reason for that, the reason that you're able to say that is because it's given. That's how every proof must start. Okay, either with what is given or what is marked. Start with what you know. And it may be helpful if you want to mark in the diagram here that angle 1 is congruent to angle 3, go for it. Right? If that helps you visualize it, mark this however you want to. Okay? Now, we look for what can we conclude? What statement can you make? Eli?
Will we lose points if we don't write the given?
Yes.
But it'd be we already know.
Your question was, will you lose points? I said yes.
How many points are
So there you go. Okay. Finn.
Well, see, 1 and 3. 3 minus 1 is 2, but 1 plus 3 is 4. So that's an improvement.
No one write that down. Izzy.
Vertical angles. So 1 and 2 are vertical and then 3 and 4.
Okay, so here's a little tip for writing proofs. If we have to prove that angle 2 is congruent to angle 4, angle 2 or angle 4 aren't included yet. We have to introduce them, right? We have to somehow introduce angle 2 and angle 4 to the party here, okay? And Izzy is doing that by saying that in step 2, she's knowing that angle 1 is congruent to angle 2. Because of why? Vertical angles. Okay? Now, because she then said that angle 3 is congruent to angle 4, because these two things have the same reason, because of vertical angles, you can include them in the same step. Okay? You're allowed to do that. You can keep them separate steps. You can say angle 1's, oh, why did I write step 3 then? Sorry. You can say angle 1 is congruent to angle 2 in step 2. And then, like I did, step 3, angle 3 is congruent to angle 4. Or you can just say, in step 2, I'm saying both of these things because
I know the next one.
of vertical angle.
Can I just do VACT?
Hold on.
What was your name?
Thank you.
Yep.
Yellow. Who's? She is in Miss Fields' room right
Who is it?
If it's in your home,
Um,
she's in Thomas's.
now? She's in 7KS, and I guess they're in Thomas's room right now. Yeah. Okay. Bye-bye. They just like to talk to me down there. Okay.
Mr. Schultz,
Hold on. Come on
can I
back.
just put
Come on back.
VACT?
Come on back. Come on back. I want you to write out vertical angles.
Wait, you have to say.
It's not write out vertical angles. Yep.
You have to say vertical angles are congruent because that's what it says on the vertical angle.
No, you don't write the definition. You write what the theorem is. You can leave off congruence theorem if you want to. Vertical angles is good enough, but don't write VACT. I want you to know what that actually stands for.
Can I write VACT
Okay.
on the test or no?
Just no. Just hold on. All right. So angle 1 is congruent to angle 2. Angle 3 is congruent to angle 4. We know that because of vertical angles. Ultimately, we need to prove that angle 2 is congruent to angle 4. How can we do that here? Cole.
Can I say it?
Sure.
Never mind.
Real.
So since angle 1, angle 2 are congruent,
Okay.
angle 3 and angle 4 are congruent, then 2 and 4 would be congruent because 1 and 3 are congruent.
And what property would you use for that?
Transitive.
So here's the thing about the transitive. The transitive property can only include 3 parts.
What?
Okay? The transitive property says if A is B and A is C, then B is C. There are 3 parts there. The way that we have it set up here, it's actually kind of 4 parts. It says if 1 is 2 and 3 is 4 and 1 is 3, then 2 is 4. That's 4 parts. The transitive property can't have 4 parts. So there's an intermediate step we have to do first. And this is why proofs get pretty annoying, because you have to be this specific. Okay? Nathan?
Reflexive property.
No.
Substitution.
Substitution. What are we going to substitute here?
You can substitute 3 for 2 or 3 for 1. You can since 1 and 3 are congruent, that means 3 and 2 are congruent as well. So you can just put 3 is congruent to 2, and then you have 2 properties which you can use in the transitive property.
Okay. So to summarize what she just said, okay? Knowing that 1's congruent to 3, and knowing that 1 is also congruent to 2, we can replace angle 1 in this statement with angle 3. And you don't have to, I'll do this in red because you don't have to write the arrow here, but I'm showing you what we're doing here. We're replacing angle 1 with angle 3, which allows us to write the statement angle 3 is congruent to angle 2. Right? Because if 1 is congruent to 3 and 1 is congruent to 2, we can substitute angle 3 in for angle 1 and state that angle 3 is congruent to angle 2. Okay, we're not done yet. So hold on. The substitution property says that you can replace equivalent values in an equation or expression, right? We know that 1 and 3 are the same. So if I say that 1 and 2 are the same, that's the same as saying 3 and 2 are the same.
Like, do you have to explain
Yes.
what you're doing and that stuff?
Well, your explanation is substitution. Okay? Now, because we are using 3 parts here, we're using 1, 3, and 2. You could also make an argument that it could be the transitive property. So either one would be acceptable because it does include 3 parts. Okay? But what we did was we substituted angle 3 in for angle 1 because if 1 is 3 and 1 is 2, why not just say the 3 is 2? It's all the same thing. Okay? Sam?
Oh, then when you plug in 4 for the 2? Or then it would be...
So from this point, right, we ultimately want to say that 2 is congruent to 4. If 3 is 4 and 3 is 2, then 2 has to be 4. And what's the reason why?
Transitive property.
Again, you could either use substitution
Can we put
or
that in the
transitive.
same step?
You could put them in the same step because of the same reason. I separated them just so you can see the thought process here. It's less obvious than with the vertical angles there. But technically, yes, they could go in the same step. Okay? Listen, it doesn't make any sense if you're not paying attention, if you have not taken the time to study these terms and these vocab words. Okay? That is the key. Right? You are going to be you're going to be in a lot of trouble if you can't come up with these theorems, these postulates, these rules here. Okay? You can use a help sheet. You can put them on a help sheet. Like they're all there for you. But if you're not paying attention and following along, you're not doing yourself any favors whatsoever. Geometry is not just here's a triangle. Okay, geometry is what relationships can we make, can we find, can we conclude about the triangle. And it all comes down to knowing these reasons. Colin.
So are we done with this one? Because
We are done.
Yes.
We've done it. Huzzah. Okay? Once a statement matches the proving statement, then you are done. Andrea.
So So with what you've shown me there, wouldn't you argue that the substitution property and the transitive property are the exact same thing?
In this case, they are because we're involving three different parts. Not all the time though.
Really?
Mhm.
Like,
Better.
can you
Okay,
absolutely not need it?
I can't right now, I'm being summoned. That's how you math, folks. Stay in your seats.